So we're going to go through the test now. I'm not going to go through all of the different methods. I'll go through the most standard method that you chose. However, for that bonus mark part, if there's any issues, right, like you did the trig substitution, then you did the hyperbolic. When we go through the trig one, check the hyperbolic as well. If I left anything out, put a big star, and then make sure you put your test in the box. Okay, very big star so I can see it, and then I'll check it at the end. If there's any issues with adding up of the marks, just check that as well. Put a little star, and then I'll check the adding again at the end. Okay, any questions before we start? Okay. So the mark allocation was pretty simple, 3 marks. So substitution, calculation, answer, basically. Yeah, so just check for that as we go through. So question number 1. So this was all integration by parts. So I gave you the hints for what to do. Remember, for the class test 2 and the June test and the final exam, there's no hints given. So for class test 2, June test, final exam, it will just be question 1, evaluate the integral. It will be all mixed up from the test. So some of it will be integration by parts, some of it U substitution, but it won't be question 1, integration by parts, question 2, trig. It's all mixed up. Okay, so just be careful of that. Okay, but here we know integration by parts. So let U be x, dv is tan squared. Okay, so we know this. So du is dx. V, that's going to be tan x minus x. Right, you change it to sec squared, then it becomes tan x minus x. Okay, so if you got all of that, that will be 1 mark for the substituting bit. Then you do your substitution, integral u dv is equal to uv minus integral v du. You got all of that, you got your 1 mark there. Then your next integral, and then the final answer, right? That will be your 3. So substituting, so integral u dv equals uv minus integral v du. Okay, so you got all of that with the substituting. That will be 1 mark. Another mark for that integral, and then your mark for your final answer altogether. So this is going to be x tan x minus x minus integral of tan. What's that? Integral of tan. Someone said Linsec. Yep. Oh yeah, sure. Sure. And then we have minus and a minus, so that will be a plus half x squared. Some of you simplified further, so you did the x multiplied in that first bracket. That's fine. You didn't lose any marks if you didn't simplify. So if you got all of that, you got your 3 marks. If you left things out, that's when I started subtracting marks. So if you left out the x for the integral tan x minus x, you lost a mark there. If you left out the plus c, that was minus 1 or minus a half. If you swapped your u and your dv, I think that was just 0, okay, because you couldn't go further than that. So it should be 1, 2, 3 marks for this. If anything's missing on your test, just put a star, and then I'll check it afterwards. Any questions on this one? Okay, so pretty straightforward integration by parts. You couldn't really do another method. If you did do something else, I gave you the marks for that. But this was the standard way. Okay, number 2, arcsine. There was quite a few ways to do this. If I did skip one of your methods, again, just put the little star. But the easiest one is to rewrite this like an integration by parts. So we do a u substitution first. So u equals arcsine x. So that makes sine of u equal x. So cos u du equals dx. Then this becomes the integral of u squared cos of u du. Right, now it's a bit easier to do the integration by parts. We had something similar to this. I'll just put on the side here, integral e to the root x. Remember this one we did a while ago? You have to do the u substitution first, and then it becomes integration by parts. I think these two were also in the tutorial, where you do the u sub first. You could have done it quite a few other ways. In the full memo, I did list them out here. Over here, so 1.2, all of these. Those were the acceptable answers. But this one was the easiest one to do. So here you could have done it the long way with u dv, or you could do that table method that we did. So that will be di. So d, that's the derivative column. So we put the u squared there. And then I, that's the integral column. We put cos of u. So it will be 2u, 2, 0, and then we can stop there. Integral of cos, that will be sine. Integral of sine, that will be minus cos. Integral of cos goes back to sine, so we have minus sine. Then we do the diagonals, and then it's plus, minus, plus, minus. Remember, the signs alternate plus, minus, so you start with the plus on the first row. Okay, so this becomes u squared sine u. Then we have a minus and a minus over there, so that will be a plus. And then we have a minus. Okay, then going back to the arc sine, so u, that will be arc sine. Then sine of arc sine, that cancels, so we're just back to x. Cos, sine squared plus cos squared is 1, so this will be root 1 minus x squared. And again, sine of arc sine, that cancels, so we just have x. Plus c. Again, 1, 2, 3 marks, so 1 mark for your substituting, 1 mark for the integral calculation, and then 1 mark for your final answer. Okay, that was the standard mark distribution. Again, you lost marks if you didn't finish the substitution. You lost a mark there. If you didn't put the plus c, I think it was minus a half. If you made a mistake over here, you lost 1 mark, but then I checked what you did afterwards. So you didn't get 0, just making like a sign mistake or something like that. Okay. Again, the other methods, similar marking scheme for that. Any questions for this one? Okay. Again, there's the other methods in that full memo. You can look through that to check for those other ways. Okay, number 3, that was the one with arctan. Okay, so this one was just testing if you know that u must be the inverse. So arctan, that's an inverse function. We let that be u. Everything else, we let that be dv. In that case, it's just the dx. So u is arctan. And then dv, that's everything else. So that's just the dx. Okay, du. So a lot of you messed up with the chain rule, kind of messed all of your logs up afterwards. So the derivative of arctan is 1 over 1 plus whatever's inside there squared. So a lot of you got that part. So 1 over 1 plus 1 over x squared. But then we must do the derivative of the inside as well. Okay, so it's not just the outside part, it's f prime times and then the inside part g prime. So the derivative of 1 over x minus 1 over x squared. Yeah, a lot of you messed up over here. So I think you got part marks for that. But then the rest of it, your substitution would be wrong. And then your integral, you wouldn't be able to do that. Okay. So the mark kind of stopped there. But if you got this, then you could simplify. because the x squared can multiply in that denominator. So this becomes minus 1 over x squared times 1, so that will just be x squared, and then plus 1. So you could simplify like that. And then v is just x on the side here. Okay, so let's put it all together. So integral 1 to root 3, arctan x, arctan 1 over x dx, uv with the bounds, so that will be x arctan 1 over x from 1 to root 3, minus, but we have another minus there, so it will be a plus, integral from 1 to root 3, x over 1 plus x squared dx. Right, and you see if you didn't do the chain rule, now your substitution there would be wrong. Right, because you would just have 1 over 1 plus 1 over x squared as your integral. You can't, you can't solve that nicely. But here it's pretty straightforward. Use substitution at the bottom. So it will just be a half 1 over u. Okay, so just normal log. The first one, you have your calculators right, you just substitute. So this is going to be root 3 arctan 1 over root 3 minus arctan of 1 plus 1 half. Again, this will just be a log because of the u at the bottom. Again, you just substitute, you'll get your answer. So this will be root 3 arctan 1 over root 3 minus arctan of 1 plus half natural log. Root 3 squared, so it'll be 3 plus 1, so log 4 minus, and then half log 2. Okay. You have your calculators, you can simplify further, but I'm not too worried about that. Yeah. So again, the marking was 1, 1, 1 for the 3 steps. Okay. Again, any issues, you put a little star. I'll check it afterwards. Okay. Any questions with this one? All good. Okay, again, so you have plenty of time for the test, but remember for the exam, it's a fixed 3 hours. Don't waste your time, with extra simplifying at the end. Right, you got your half log 4, don't write it in terms of log 2. It's too much work there. Just leave it like that, it's fine. I can see what you're doing. Okay. Yeah, for the test, it's fine. You got time. For the exam, you don't want to waste your time too much with that. Any questions for the question 1? All good. Okay. Again, there were a few other ways of doing this. I'll let you look at the memo for that one. Okay. Number 2, trig integrals. These ones didn't have too many methods. Some of them you could do it 2 different ways. I gave the mark for that. But it's basically what we did in class, right? If the powers are even, you do the one thing. If it's odd, you do the other thing. I just mark based on that. Okay, let's have a look at the first one. So number 1. Integral tan cubed. Okay, like we did in class, if it's odd power, we want to change that to even. Because if it's tan squared, we can do the sec squared minus 1. So here we're going to split it into tan and tan squared, so we can use that identity. Okay, so if it's odd, you split it up so you have an even part to it. Then tan squared, we can replace with sec squared minus 1. And then here we can just do it as 2 separate problems. So here we'll have tan x sec squared x minus tan x dx. So the derivative of tan is sec squared, so it's just half tan squared. And then the integral of tan, that's just ln sec. Okay, pretty straightforward for this one. Again, 3 marks. So your identity, splitting it up using the identity, 1 mark. Evaluating the 2 integrals, another 1. And then your final answer, that's your 3 marks. Okay, if you left anything out, then you started getting -1, -0.5 in your answers. Okay, any questions for this one? Yeah, pretty straightforward. There was a few other ways. Again, you can look through that. Most of you did it this way. Okay, next one, number 2. Integral tan to the 5 sec cubed. I think we did this one in class, but both of them are odd. So what do? Both are odd. We take out sec tan. Yeah. Yeah, because if both are odd and we take out sec tan, then it becomes even, which is what we want. So this will be integral tan to the 4 sec squared sec x tan x dx. So what does u have to be so that we get du as sec x tan x? The derivative of what is that side? Sec, yep. Okay. And then we have to do the substitution. So here, this is equal to the integral. So we've got tan to the 4. We treat it as tan squared again. So this will be sec squared x minus 1. That will give us tan squared, and then we just square it to get tan to the 4. Okay. And then the u substitution now. So this will be equal to the integral u squared minus 1 squared, another u squared, and then du. Okay, so that was the 1 mark for the substitution. So if you knew that u was sec, and then you could substitute u as sec, that was the 1 mark. Another mark for integrating this, so you expand it out, you integrate, and then another mark to go back to sec. 1, 2, 3. Okay. Again, if I missed anything, just put a star. Okay, but that was the 3 marks. So substituting, evaluating the integral correctly, and then substituting back. Okay, 3 steps. So let's go through this one. So this was the integral. U squared minus 1 squared again. So u to the 4 minus 2u squared plus 1. A few of you forgot to put the u squared back inside the brackets. So you got the brackets right, but then you didn't times the u squared. So you lost your integration mark there. Okay, just be careful with that. So this is integral u to the 6 minus 2u to the 4 plus u squared. So 1 over 7 u to the 7 minus 2 over 5 u to the 5. Sorry, that's a 5 there. Okay, so that will be the second step. So second mark. And then finally, you put your sec back inside, you get your answer. Sorry, sec to the 5. Okay. A few of you didn't substitute your sec back inside at the end, so you lost your mark for that. There was only a couple, so I'm not too worried with that. But that should be your final answer there. Okay, again, if you left out your plus C, you lost a half mark there. If you didn't do the integration correct with the U, you lost a mark there. But that was the basic idea. Any questions before we move on? Yeah. And then number 3. So we have 1 over cos x minus 1 dx. I think it was this one I set for homework when we were doing these. I'm not too sure. So we have cos x minus 1. We want it to be cos squared. So we times top and bottom by cos x plus 1, right, for that conjugate. So we times by cos x plus 1 over cos x plus 1. That will give us the cos squared that we need for the bottom. Okay, at the bottom, that's just the difference of two squares, so cos squared minus 1. So this will just be minus sine squared at the bottom. Right, so cos squared plus sine squared is 1. So cos squared minus 1 is minus sine squared. So I didn't give part marks for that side working, but the bottom there should be minus sine squared. So this will be integral cos x plus 1 over minus sine squared x dx. We can split this up into two problems. So this will be minus the integral cos x over sine squared minus the integral 1 over sine squared. Or if you want to write this as cosec squared, it's a bit easier to see what the answer is. Right, 1 over sine is cosec, so we have cosec squared. Okay, and then here we have integral cos over sine squared. You could just write the answer down if you know it, or you could do a u substitution. So u equals sine, so du is cos, so we have 1 over u squared. So this will be 1 over sine. And then the integral of cosec squared, you should just know that one. That's minus cotan. Okay. So the integral of sec squared and cosec squared, you do need to know those. If you change the 1 over sine to cosec, that's fine. You didn't have to do that. So you could have written this as cosec plus cotan. Okay, that's not really needed. If you left it as 1 over sine, you got all the marks for that. So same thing with the 3 marks. So simplifying this over here with that conjugate, that was 1 mark. Evaluating the integrals at the top there as 2 separate ones, another mark. And then your final answer, 1 mark. Okay. Any questions for this one? Good. Okay. If you made some sign mistakes over here, you lost a mark there. Okay. So at the bottom there, it should be minus sine squared. If you didn't have that, you lost a mark. Integral of cosec squared is minus cotan. So you lost a mark there if you didn't put the minus. And then the other minus was the integral of 1 over u squared is minus 1 over u. Okay. So if you made any sign mistakes going through, you lost a mark for that. Okay. Any questions for this one? All good. Okay. Next one was the trig substitution. I'm just going to do the normal trig substitution. The hyperbolic one, you can have a look for that. So number 1. At the bottom there, it's not in the standard form of a squared plus x squared or x squared minus a squared or any of that. So we need to complete the square. So complete the square. So we have 3 minus 2x minus x squared. Not so bad to do. So this will be equal to 4 minus x plus 1 squared. Right, you just take half of the b, so half of 2 is 1, put it in the brackets, and then the leftover will be 3 plus another 1, so you get your 4. And then this is now in the form a squared minus x squared, so we can do the substitution from there. So we have the integral x squared over root 4 minus this. So it's a squared minus x squared, so that will be a sine substitution. So on the side, we have x plus 1 is 2 sine theta. because of the 4. We get the 2 there. So dx, that will be 2 cos theta d theta. Okay, then you substitute inside and you got your 1 mark. So this will be the integral. X squared at the top, that will be 2 sine theta minus 1. That gives us x, and then we need to square it. A lot of you forgot to square the top. Okay, it was like more than 5, so I'm a bit worried that you're not reading the questions carefully or you're rushing. But please, when you do your substitution, check that you're substituting correctly. Okay, so the top is x squared. So you find your x and then you square it. Too many of you were just putting 2 sine theta minus 1. Okay, right? You're doing a whole nother problem. You just mess everything up afterwards. Okay, so please be careful when you're substituting. So in the top, 2 sine theta minus 1 squared. In the bottom, we're going to get 4 minus 4 sine squared. So 4 cos squared. So once we do the roots, we get 2 cos theta. And the top, we also have a 2 cos theta from the dx. That cancels. So this will be 4 sine squared theta minus 4 sine theta plus 1. Right. This is just your normal trig integrals. Now, sine squared, we do have to change to the double angle. So this is going to be the integral 4 times half 1 minus, if it's with the sine. Okay, minus 4 sine theta plus 1 d theta. So 4.5, that'll just be a 2 there. 2, and then we got another 1 there, so there'll be a 3. Okay, and then integrating this, that gave you your second mark. So this will be 3 theta minus 2 over 2, so that'll just be a 1. So it'll be sine 2 theta. And then sine, that becomes minus cosine, so the minus becomes a plus. Okay, so you should have something like that. So that will give you your other mark, and then your final mark is just substituting back. So this will be 3 theta minus 2 sine theta cos theta plus 4 cos theta plus c. So we have to put the x back for the trig function, so we draw a little triangle. If theta's over here, we've got sine theta is x plus 1 over 2. So x plus 1 must be over here. And then 2 must be here. And then the other one must be 4 minus x plus 1 squared. That's just filling in your thing there. And then finally substituting, so we have 3. Theta, that will be arc sine of what we had before. Minus 2. Sine theta, x plus 1 over 2, like we had before. Cos theta, we just read from the triangle. Plus 4, and again, cos theta, we just read it from the triangle. Okay, and then that will be your other mark. Okay, so 1 mark for the trig sub, 1 mark for the integral, 1 mark for your subbing back. Okay, any questions for this one? Okay. And then you got another mark for your little picture over there. So it was out of 4, I gave you extra mark for your picture. Okay, but the main calculation part was 1, 1, 1. And then the picture, the additional. Okay, number 2. So this was 1 over x squared plus 1 squared. So it was like x squared plus a squared in the bottom there. So that means we must use tan. So the derivative of tan, that's x squared. So this will be integral. At the top, let's put this x squared there. In the bottom, we have x squared, so tan squared plus 1. Squared again. What's tan squared plus 1? Sec squared, yeah. So sec squared and then squared again. So we have sec to the 4 at the bottom, sec squared at the top. So it will be 1 over sec squared. Now, we don't really want to work with the sec squared. So remember, sec is 1 over cos, so it just becomes cos squared. Oh, that's a bit easier to work with. So cos squared, we use that double angle again, but now with a plus, because it's cos. Yeah, so we have 1/2. Yep. So integration, that gave you your other mark. And then we go back. So this will be half theta plus half sine theta cos theta plus c. So theta, that's just going to be arctan from the substitution we did. We need the other two, so let's draw the triangle. So tan theta is x. Remember, it's not just x, it's x over 1. So we end up with that. So sine will just be opposite over hypotenuse for the first term. So we got the arctan from the substitution. This will be opposite over hypotenuse. Pen. Opposite over hypotenuse for the first one, and then cos, that's just the adjacent over hypotenuse. There we go. Okay, and then the adjacent over hypotenuse, that was the one. So you could multiply the denominators together, but that's not really needed. If you got this for your last step, that will be the last mark there. Okay. Any questions for this one? Okay, so again, 4 marks. So your substitution, integration, final answer, and then your picture on the side. Okay, last one, number 3. We've got a squared minus x squared. So that will be sine because of the a squared minus x squared. So here, oops. Okay, so x squared over 1 minus x squared. So x will be sine there. Okay, so you had to do this way first. You could do partial fractions with this, but that would only be counted as your bonus marks. Okay, you can't do partial fractions as your main answer because it was a trig substitution question. Okay, so some of you skipped the trig substitution completely and went to partial fractions. I can't give you the mark for that. Okay, you have to do the main one first, then you get your bonus marks after. Okay, it's not just hope you get the bonus right. You have to answer the question first. Okay, so let's put in sine. So this will be integral x squared is sine squared. 1 minus x squared, so 1 minus sine squared. And then dx, that was cos. Okay, so 1 minus sine squared, the bottom we get cos squared, yep. Okay, so we stuck here. There's a few things you can do. I'm going to change the top to cos squared so we can cancel with the bottom. But there's other ways to do this. So the top sine squared, I'm going to write as 1 minus cos squared. Right, because the cos squared will cancel there. So this will be the integral 1 over cos. We can write that as sec. And then cos squared over cos, that cancels one of them. So that will just be cos. Okay, integral of sec. Again, that's just one of the ones you need to know. So that's sec plus 10. Okay, so we end up with that. So that was 2 marks for that, and then substituting back. Let's do that here. We draw a picture. That's another mark. So theta, sine theta is x, but remember it's x over 1. So we have that. Yeah, and then we can put our put the things back. So we have ln sec, that will be hypotenuse over adjacent because we swapped them around. Tan, opposite over adjacent. And then sine, opposite over hypotenuse. Okay. You could simplify this further with that log, but again, that's not needed. If you got to this stage here, you got your 3 for the calculation, and then another one for the diagram. Okay. Any questions for this one? Okay. So nothing really too tricky. If you knew your substitutions, you could do it quite easily. Anything on the trig stuff before we move on? Oh, good. Okay, then the last one. So please keep the talking down. Okay, so the last one here, partial fraction decomposition. So it was open book, so you had all your notes with you, but I gave you the steps anyway. A lot of you just ignored step 1. I don't know why. I gave you the steps, you had your books, but you just ignored step 1. You got 0. Right? If you ignore step 1, you can't solve for a, b, and c, so you get 0 for that. You can't split it up and do the integrals, you get 0 for that. What am I supposed to give you? Right? So please, if I give you your steps, follow the steps. There's even the marking on the side there. So I don't know why you would just skip step 1. But let's go through it. So long division. So we have the top part here. And we're dividing by x cubed plus x squared. So x cubed goes into x cubed once. So we just get a 1. So this will be x cubed plus x squared. Then we subtract them. So we get 3x squared plus x minus 1. 1 mark for that. I think that was the easiest mark out of the test. Okay, so step 1 done. We've got that. Step 2, we need to split it up and then solve for the a, b, and c. So let's do that. So I'll factor it now. So x cubed plus x squared, we can take out an x squared. Okay, so we know how to split it up now. So this is going to be equal to, we have 1 from the division, plus 3x squared plus x minus 1. And the bottom we've already factored, so we can just put that there. Okay, so let's split it up. So we're going to have a over x, b over x squared, and c over x plus 1. So a over x, b over x squared, c over x plus 1. If you wrote that in a different order, your a, b, and c will be different to mine. but your final answer will be the same. Okay, so don't worry about the ordering. If you put C, B, A, for example, your numbers will be different. Your final answer will be the same, so you got your marks anyway. Okay, so don't worry about the ordering for that. Cross multiply, so we get 3x squared plus x minus 1 is a x plus 1 plus b x plus 1 plus c x squared. Okay, there's a few ways to do this. Let's multiply it out, compare coefficients, or you could choose values of x, whichever way. I gave you the marks for that. So that will be 3x squared plus x minus 1. So we have ax squared. Then we have cx squared. Then we have ax. We have bx. And we have a b. I'm just putting it in order so we can compare the coefficients there. So this is going to be equal to a plus cx squared, a plus bx plus b. So this will be 3x squared plus x minus 1. So left-hand side, right-hand side. So we got minus 1 and b. So b must be minus 1. A plus b must be 1. So a must be 2. And a plus c is 3. So c must be 1. Okay, you got your, I think that was 2 marks. Yep, 2 marks for that. Setting up your equation, solving for a, b, and c, that was your 2 marks. I accepted any method to solve. If you did this way, you got your marks. If you substituted different x values, you got your marks. Then someone sets up a matrix and found the inverse. It's a bit long, but you got your marks. Whatever method, you got your 2 for that. And then lastly, the integration. So we have to do the integral of 1 plus. I had a for my first one, so it will be 2 over x. Then b, that was my second one, so it's minus 1 over x squared. And then c over x plus 1. Right, there's no tricks or anything for this one, it's just normal integration. So x plus 2 ln x plus 1 over x plus ln x plus 1. Right, there was no, arctan or any funny things there. It's just normal integration there. And I think that was the other 2, yeah. So splitting it up like this, doing the integration, you got your other 2 marks. If you forgot the plus c, you lost a mark. If you forgot the x from carrying down the 1, you lost a mark. But if you got the other stuff, you got your 1 mark there. Okay, any questions for this one? Okay, so this took me under 43 minutes to do the test in front of you. So I think you had plenty of time. Okay, 1.5 hours for you to do it. I did it in 43. I think you can say the timing was fair. Okay, plus it was open book, so that helps a bit more. All right, any questions for these questions here? All good. Okay, so please put your stars wherever I missed some things. Check the adding. If the adding is wrong, again, put a little star. I'll double check that afterwards. The boxes over there, please put your test there if there's things for me to check. Otherwise, you can go. We won't do anything more today. Okay, tomorrow we start the new section on applications of integration, finding volumes of shapes. Okay, so all of the stuff you learned with Dr. Chetty about the 3D shapes, and you view it from this way, you view it from this way, all of that stuff we're going to go over. Okay, so you're going to have some funny, weird shape, and then you need to find the volume of it using integration. Okay, any issues before we go?